Hello everyone. In this video, I'll show how I use Doenba Edit to write, edit, and typeset Section 4, Predicting Metal Counts with Probability Intervals, Backtest Validation, and Sensitivity Analysis. Earlier I noted that I fitted a negative binomial generalized linear model, NBGLM, with a log link to each metal category, using the normalized primary dataset to forecast each country's medal totals for the 2028 Olympics. Although the NB model can be appropriate when many countries have zero medals, our dataset excludes zero-medal countries, which reduces variance relative to the mean. In this situation, the NB variance introduces an unnecessary parameter that actually degrades generalization because overdispersion is mild. Indeed, backtest comparisons confirmed that the Poisson GLM produced more reasonable predictive performance. Thus, I decided to only write up prediction results using Poisson GLMs for each metal type. To strengthen my initial assessment that Poisson is better, I also asked Doenba for suggestions to help explain it. I found Doenba's response helpful, so I copied it into the writing area, edited and rephrased where necessary, and ensured the mathematical expressions were typeset correctly. Because this section covers multiple subtopics, I created second-level subsections to better organize the presentation. While writing, I used refine and rephrase to improve my prose, and consulted Message Doenba for suggestions whenever I deemed it necessary. I created and drafted 3 subsections on justification for the use of Poisson GLMs, model formulation and evaluation metrics in backtests. This is the preview of this section so far. It looked good. Next, I added a new subsection presenting the prediction and backtest results. I ran the Python code recommended by Doenba to fit 3 Poisson GLMs, produce predictions with probability intervals, and conduct backtests to evaluate the models. Major programs may be included in the paper's appendix. I rounded the predicted results and adjusted them so that the predicted medal counts for all countries summed to the cap using the largest remainder method, and rearranged the listing of countries in descending order by gold, silver, then bronze. This CSV file shows the prediction results. Now let's see how well the prediction results are. For this, let's examine the backtest results as shown here. Here are my interpretations of the backtest results. MAE ranges from 1.20 to 1.78, which is less than 1% on average, relative to cap greater than 300. RMSE ranges from 1.87 to 3.39, indicating low spread in errors relative to the scale with possible outliers. SMAPE lies between 66% and 78%, showing moderate relative accuracy, which suggests there is room to reduce percentage errors, but it is not prohibitive. Spearman error lies between 0.70 and 0.77, signifying a strong monotonic relationship between predictions and actuals in terms of ranking. Spearman P is close to 0, indicating there is a statistically very significant correlation between the predictions and actuals in terms of ranking. Given the combination of sub 1% average absolute error, strong rank correlation, and moderate SMAPE, the model's predictive performance is acceptable for most practical purposes, especially where ranking is important. There remains scope to further refine the model to lower the SMAPE and RMSE. I then compared the predicted medal counts for each country at the 2028 Games with their 2024 medal counts to determine which countries are expected to see increases or decreases in medals. The following lists the top 10 countries projected to improve their gold medal totals and the bottom 10 projected to lose gold medals, alongside the top 10 countries expected to raise their overall medal counts and the bottom 10 expected to see declines in total medals. Finally, I presented the sensitivity analysis results in a subsection, describing the procedure used to evaluate predictions from the Poisson GLM with respect to the parameters team size and cap, with the assistance of Doenba, and explaining how each metric indicates whether the model is sensitive, moderately sensitive, or insensitive to a given parameter. I ran a Python program suggested by Doenba to produce a sensitivity table, which is shown here. This section is now complete and presents a detailed solution to the main task, We will now give a brief preview of its contents. That wraps up this video. Thank you for watching. See you in the next one.